Okay, so for those of you who are still having questions on this other part of the tutorial sheet, this is what you do for question 6. So question 6a there, all we need to consider is just the sum of the torques. Okay, we have the force F directed towards the left and is perpendicular to the distance x. Okay, so notice that our turning point here is the point P indicated here. So we take P as our pivot in this case. Okay, so the distance x away from the center of gravity will give us a torque which is anti-clockwise. Okay, then the normal force also acting upwards and is perpendicular to the total distance of this block, or rather the base. Okay, so we take the sum of the torques, which is equal to 0. We'll have F, which is perpendicular to H, being equal to the normal force perpendicular to the distance x, okay, from which we can obtain the value of F as 42.5 newtons. So notice here, it's not the 45.7 as stated in the question, because the mass that was given there was 65 instead of 70 kgs. So if you use 65 kgs, you are finding the value of F to be 42.5 newtons. Okay, then part B here is just a matter of explaining about the stability of an object when the base is widened. Okay, so it's just a matter of considering the stability and the center of gravity here. Okay, then part C again is similar to part A, only that in this case here, the value of x that we assumed in part A has increased from 0.1 to 0.45 meters. Okay, so in that case we still have our F, and the perpendicular distance is h to this F. We also have our turning point at P, okay, the bottom left corner here, and also the weight acting towards the center, W. Okay, so F is perpendicular to H, and also the normal force is perpendicular to the distance, 0.45 meters. Okay, so from this we can get the sum of the torques as indicated here. We know that the sum of the torques must equal to 0 about a fixed point P. Therefore we have that F times H equals Fn times x. Okay, so this is the sum of our torque. Notice that the normal force is causing a clockwise torque, therefore it is negative, and that's why it has been put to the right side here to get rid of the negative sign. So if we work this out, we are going to obtain the value of F again as 206 newtons. Okay, so we go question 7. So for question 7, unfortunately I couldn't paste the question here, but the solution is here. So for this question, we have the mass of the leg as well as the cast being 15 kgs. Okay, we also have the hip joint at this point, the hip joint. Okay, so yeah, so this is the hip joint here, and the 15 kgs is at the center of gravity for this particular system. And notice that there's a mass here that is pulling downwards, okay, but the tension is acting upwards. Therefore this tension is equal to the weight of this mass, and also the same tension will be the tension will be the same tension acting in this other chord here. Okay, so therefore this W is the same as mg. Okay, mg. So if we are to consider the sum of the torques, we are going to get, notice that this mg let me just change the color here. Okay, so notice that this weight here, okay, the W here is perpendicular to the distance of 0.78 meters. Okay, so it is going to cause an anti-clockwise torque. Therefore, we are going to get the torque from this weight as the weight times the perpendicular distance, which is 0.78. Then we also consider this. Okay, since our pivot is here at this point, okay, if that is our pivot, then the mass at the center of gravity is creating a clockwise torque. Okay, so this and the perpendicular distance being that one is a negative. Okay, we know that clockwise torque is negative, therefore it will be minus the perpendicular distance, which is 0.35 times 15 kgs times 9.8. Okay, so we multiply by 9.8 to work with the weight here, which is a force. Right, so similarly on the left hand side, we know that weight is the same as mg, so we have our weight multiplied by the perpendicular distance minus 51.45 must equal to 0. Okay, so from this we can now find the value of m. Okay, we find this value of m, knowing that g is 9.8, we simply put in the value there, and we are going to discover that m is equal to 6.73 kilograms. Right, so yeah, just take note of the few corrections I'm making here. I will have to apologize for the PDF I sent earlier because the time I was solving that, I think I had a bit of pressure. I had assignments as well to submit, and yeah, that was a time of politics. Nevertheless, take note of the corrections and please follow through. Okay, so we also have question 8 here. Okay, so question 8 is another question that requires us to find the position of the third girl there. So here, well, yeah, you consider the sum of the torques. It has to be 0, of course. So we have the sum of the torques being equal to 0, and since we want to find the position of the third girl, and we have our pivot this time at the center, so let us consider all the torques. Okay, so we have 45 kilograms causing an anti-clockwise torque over a distance of, so notice here that this force here acting towards this end is only perpendicular to a distance from there to the pivot. Okay, therefore the distance will be 3.2 divided by 2. That's why we have 45 kgs multiplied by 3.2 over 2 minus 35 the other end. Okay, this other one also is only acting a distance of this, okay, from there to there. Therefore we will have that 35, since it's a clockwise moment, it will be 35 multiplied by 3.2 over 2. Then we also have the moment of this girl, which is there, and the distance is x. Okay, so 25 kgs multiplied by x, and because it is a clockwise moment, it is negative, therefore have minus 25x, all this being equal to 0. So if we work this out, we can simply find the value of x. Okay, the rest is mathematics, and when you work out, you should be able to find the value of x as 0.64 meters. Okay, so this is where the third girl must be placed for the system to balance or to stay in equilibrium. Okay, then we also have question 9. So question 9 here requires us to find to find the center of gravity for this person who is lying. Okay, so in this case, let us consider also the sum of the torques. Yes, I think I posted something earlier on this question in a PDF, so there's also a correction for this one, I think. Okay, so let's look at this. We require that the sum of the torques is 0 about our pivot P. So because we are measuring our distance from her feet, which is here on our right, we take our pivot to be at the feet. So if that is our pivot there, then let us see the sum of the torques. Okay, so if that is our pivot, we have the total mass, okay, acting at the center of gravity there, mass 1, meaning that the mass at the head here plus the mass here, we call them M1 and M2. So we'll have the total mass of M1 plus M2 multiplied by G, giving us a force, which is the weight. Okay, so this total mass here is causing an anti-clockwise moment. Okay, it is causing an anti-clockwise moment perpendicular to the distance x. Therefore, for this moment, we are going to have the combination, the combined masses times G times X, okay, because the torque will be anti-clockwise. Then we also consider the other torque from the point P here, okay. So notice that the other torque will act from P, from here and perpendicular to the whole distance, like that, okay. So the mass that we have there will be M2. So the mass that we are, in fact, let me just reverse this. So the torque we're talking about, is this, from this point to that point, okay. Since this is our pivot, so the force will be acting upwards and perpendicular to the length of this person, or rather the height. So therefore, we are going to have that M1 times G being perpendicular to 1.72 meters. Okay, so that is the other torque, which is clockwise, and because it is clockwise, it becomes negative. Okay, so let us write minus M1G multiplied by the length or the height of this person, giving us a 0. Okay. So this is the sum of the torques that we have for this system. We have the torque as a result of the combined mass at the center of gravity, and the other torque as a result of the mass recorded at the head of this person. Okay, so the sum of these torques must equal 0. Therefore, we substitute the values of M1 and M2. We have times 9.x, giving us this. So we work this out, just mathematical now, and we should be able to obtain the value of x as 0.91 meters. Okay, 0.91 meters. So that is the distance, or rather that is where the center of gravity for this person is from, measured from her feet. Okay, so there is question 8 here. I was saying attempt as a quiz. So here also just take note of the forces as well as the perpendicular distances, and also knowing that the pivot point is the elbow here. Okay, so if that is our pivot point, then what force is perpendicular to which distance, and then take the sum of the torques about the point P. Okay, so this shouldn't be any problem. You can use your theta as this one if you want, or the same one given in the question. Okay, so I hope to see you trying this, but if you still have challenges, I can still assist you on the same. But just try to see whether or not you actually grasp the concept. So what I expect to see on this one is just the solution, so that I can confirm whether or not what you are doing is right. Okay.